Alright, now that we've done a review of absolute value equations, let's change that equal sign to an arrow and take a look at absolute value inequalities. Let's take a look at an example now. The absolute value of x is less than 4. So what can we plug in here such that its distance is less than 4 units from 0? Let's take a look at the definition. Remember, you can plug in both a positive and a negative value to the absolute values. So on the left side, we're going to have the positive version, x is less than 4. Or on the right side, the negative version, negative x is less than 4. Please note we did not change the inequality arrows or the value of 4 on either side. All we can change is what gets plugged into the absolute values, being a positive or a negative. The left-hand side is done. There's absolutely nothing to do with the x is less than 4. On the right-hand side, I don't want it to be negative x is less than 4. So what I'm going to do is, keep in mind, this is multiplying by negative 1. I'm going to undo that by dividing both sides by negative 1. That gives us x is greater than negative 4. Remember, when we divide by a negative, the inequality arrow changes directions. Alright, now that we have both pieces solved, the left and the right, we want to write this in standard notation. Remember, we like to write the negatives on the left-hand side, the positives on the right, so it matches the number line. So doing the rewrite, we see negative 4 is less than x. I did write negative 4 on the left, kept the arrow pointing at negative 4, so my inequality does not change. I write x is less than 4 on the right-hand side, and now we're ready to graph it. So, no equal to signs are present, so they're going to be open dots at negative 4 and 4. Less than 4 units away from 0. All these numbers are less than 4 units away from 0. Think of it, if you want, as x is bigger than negative 4, so you go right. X is less than 4, so before you go left. X lives in the middle, right directly between those 2 points. This is, as we see from the graph, a conjunction. They're connected, so we can actually rewrite the inequality as shown here. Negative 4 is less than x, which is less than 4. Alright, the next step will be to take a look at a situation like this, where you have a constant outside the absolute value bars. So absolute value of b plus 1 is less than 7. And what you need to consider here is, in order for me to apply the definition, I've got to know what the absolute value itself is greater than or less than 2. And this adjustment of 1 is kind of messing that up. So what we need to do is move this constant to the other side first, so we can create a situation similar to that on the last slide. To do that, you're going to have to subtract 1 from both sides. The opposite of addition is subtraction, remember. Rewriting, absolute value of b is less than 6. Now hopefully you see a similarity in where we're at now to the previous slides. Apply your definition. You could plug in a positive or negative value. So 1 is positive, leave it alone. b is less than 6. Or the other option, inside 1 is negative. Negative b is less than 6. One step to solve this. Divide both sides by a negative 1. Rewrite it. Inequality arrow changes. That's why this step is so important to discuss every time. Changes your inequality arrow. b is greater than negative 6. Both inequalities are simplified. I'm going to rewrite them. Over here we have negative 6 is less than b. On the right, b is less than 6. Take a look at the rewritings here. You notice the arrows point the same way when I'm in standard position. That allows me to connect them. This would be a conjunction. This is an AND situation. If I were to graph it, I would be living between the points of negative 6 and 6. Alright, so what I've changed now is I've put my constant within the absolute value bars, and we're going to see what this does to our solving process. There's nothing outside the absolute value bars, nothing to move. I can go straight to the definition. This entire chunk is what I'm solving though now. So that entire chunk, that entire quantity, x minus 10, could be positive. So we have 1 being positive again. X minus 10 is positive, greater than or equal to negative 16. Or the entire quantity inside, the whole quantity, is negative. So rewrite it with the parentheses. Now, each one in this case has something to be solved, and this is just our basic solving skills once again. So on the left, you're going to add 10 to both sides. X is greater than or equal to 26. That part is done. We don't need to do any more. On the right, you could choose to distribute the negative. I find that a lot of times when people do this, they forget to distribute to the second term. They forget to change your negative 10 to a positive. So I'm just going to eliminate that negative right off the bat by divide both sides, the entire left side, by negative 1, and the right side by negative 1. I no longer need the parentheses on the left. My equality arrow changes. I get a negative 16. Now this is a much simplified case of solving. Same as last time. Add 10 to both sides. X is less than negative 6. Let's rewrite it. X is less than or equal to negative 6. X is greater than or equal to 26. My arrows point the opposite ways. This is not set up for me to connect. This would indeed be a disjunction. So it's an or. X is less than or equal to negative 6, or X is greater than or equal to 26. So going back and taking a look at all the slides we've discussed, nothing changes here in terms of the algebra. All we're really doing is applying the definition of absolute value, meaning inside the absolute value bars you have a positive value, or inside the absolute value bars you have a negative value. From there, your solving process is the same. You use the opposite sign it gives to isolate x. And then you just take a look at your done. When you're done, is it a conjunction or disjunction? So once again, the only difference is looking at to see a positive or negative value to be plugged in. And that is a review of your absolute value inequalities.